if I look at the last one, essentially what we're doing here is we're taking a circular piece of paper. So I've got a circular piece of paper here that's got a diameter of 20. So the whole way across this thing is 20 units. And then what I'm going to do is I'm going to make cuts all around the edge of this thing. So I'm going to signify the cuts in red. And I don't know how far in I'm going to cut, but I want each cut to be the same. So I make each of these cuts, and I try to make each cut the same. And what that does is it leaves me with this inner circle. And each of these little cuts, each of these things out here, this is like a little tab that I'm going to fold up to form almost like a bowl or a dish here, a cylinder with no top. So I'm going to be folding each of these up. So the circle that I have in green here, this is basically the bottom of my cylinder, all right? And then those tabs that I'm folding in are the sides of my cylinder, all right? So what I want to do is I want to write this in terms of an equation. I don't know how far in I'm going to cut each of these. That's what I'm looking for, the size of the cut. So in other words, each of these little tabs, each of these values in red, this is x. And so that's going to allow me to write my radius and my height of this thing. Because what I'm doing is I'm trying to maximize the volume. Well, the volume of a cylinder is pi r squared times h. Well, so if I think about the radius of this thing, the radius of the circle used to be 10. Okay, from here to here was 10 units originally. But once I fold up that tab, I'm taking an x amount of space away, so my radius now is going to be 10 minus x. Okay, the radius was 10, but once I fold up that tab, which is x in length, I lose x amount for my radius, so my radius becomes 10x for the bottom of my cylinder. And then the height of my cylinder, well, is the height of each of those tabs, and the height of each of those tabs as I fold them up is x. So now when I write this equation, the volume is going to be pi times r, which is 10 minus x squared, times h, which is x. In other words, y equals, if I'm going to be plugging this into the calculator, I can leave this in factored form, times x. So now I'm just going to plug this into my calculator, so I bring my calculator back. This time I'm going to go into the y equals menu because I want to get the graph of this thing. So I do second and then the pi button, which is right here. And I just copy this down exactly the way it is. So I have my equation punched in. I'm going to go to graph. And typically, we always want our graph to start off with zoom standard. If it's not, we can go to zoom and then down to number 6. And I'm already at zoom standard. And I see just a little piece of my graph appear right here in this corner. Okay, so I have to change the window. And as I change the window, think about the x values and the y values here. The x values are never going to be negative. I'm not going to make a negative cut, so I'm going to set that equal to 0. The x value itself in terms of the maximum, as I look back at the circle that I have, the largest cut I can make, it has to be smaller than 10, because if I cut more than 10 on each side, I'm going to cut this circle in half, and then I won't be able to make a cylinder. So this has got to be less than 10. I'll set it to 15 so we can see just a little bit more of the graph. The y values, I'm not going to have a y value that's negative because I'm not going to have a negative volume, so I can set that to 0. And then I just kind of have to take a guess at the y maximum. It looked like this thing was going to be pretty big, so maybe I'll guess something like 100. And I can change the scale, maybe go by 20s, something like that, and hit graph. And what happens here is I kind of see part of this thing. I see it going up, and I see it coming back down, but I need to see more details in there. So maybe I'll go a little bit further. 100 didn't work. I've got to go further. So maybe I'll do something like 600 or 700 or 1,000 or 500, whatever we decide on. And I plug this in, and now I can see a graph of this thing. And as I look at the bottom of this graph, this is going by ones. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right here, which means I can't use any of the values over here. Even though this value is higher, that would require me to cut like 13 or 14 inches off, which I can't do because then I won't be able to make a cylinder. So essentially, I'm just looking at this first half of the graph. So if I want to maximize the volume, I'm looking for this relative maximum. Okay, so now I go to calculate. So it's second, and then right here is calculate. I want to calculate a maximum, which is number 4. And it would ask me my left bound, right bound. So when it says left bound, I go to the left of that maximum value, which is over here. And I hit enter, and then I ask me right bound, so I go to the right of that maximum value and hit enter. And then I take a guess. I get as close to that maximum value as I can, and I hit enter. And it looks like my maximum value here is the ordered pair, 3.3 repeating, comma, 465. And really what that's telling me, it's telling me that my cut, the thing it asked me about, my cut should be 3.3 inches, and that'll give me a volume of 465 cubic inches. Okay? So to answer this question, I should be making a cut that's about 3 1/3 inches in length. Okay? Hope this was helpful, and good luck on your quiz.